So the point of looping is just to repeat something repeatedly. Sounds good. Repeat something repeatedly. A block of code. If you ever find yourself copying and pasting stuff, you can be pretty sure that it could be better done with a loop. You know, yeah, copying and pasting like once, you know, if the code appears twice in your code, whatever, you know, but you're not going to just copy and paste 10 times or 100 times into your code. Instead, you're going to write it as a loop. So the idea behind a loop is that you have a test condition, and then you have a body. So it tests the condition. This is a while loop, by the way. It's known as a pre-test. I don't even think I have a slide over post-test. We might put it in there. You test the condition, and if the condition is true, you execute a body of code, a block of code. You make a function call, you do, you know, some statements, and then you go back up. Now, you know, with flowcharts, you can draw stuff that doesn't even exist. I mean, that's impossible to program with structures. And what do I mean by that? Suppose you had this, and you came in there, and you did something, whatever this something was supposed to be, x plus equals 1. And then you had this condition, whatever that condition was, and you executed a block of code, whatever that was supposed to do, and then your loop went back up like that. And that was your yes block. And your no block just, you know, kept going on and doing something like that. This is not valid code because it should loop right back up to the while statement. That's how while statements work. Yeah, you can just move this down here, you know. You could copy that because it's supposed to do this before it enters the while loop. And then we wanted it to do it again, but you can't do that because the while, you have the word while, then you have your curly brace, you have this stuff here, and then you have your closed curly brace, and up here was your x plus equals 1. You know, that's your body. It can't get back up there and do that again. So what's your solution? Your solution is to copy that statement and put it here so that it gets executed again. And I don't really like that, but that's the way it is if you want to accomplish it that way. I kind of program to try to avoid doing that. We'll talk about how at this point. There's something called a priming read, which I find really annoying. But in order to avoid doing a priming read, you have to make the body of your code a little bit more complex with what's either known as a break statement or with an extra if in there. And we will demonstrate that. I don't have a slide on it, but I need to make one. So if statements can be kind of complex, they can be pretty simple. Here's one, end of file. No, we're not at the end of file. So is the pay type equal to salary? Yeah, it is. So our pay is equal to our salary. Else, our pay is not equal to our salary. It's equal to hours times rate. You know it's an if statement because they join back together. You know this whole thing is a loop because the line comes back up to the top. When I draw flowcharts, I'll actually put an if in that diamond, and I'll put a while there to key you in even more quickly without having to watch where the lines go in order to determine whether it's a loop or whether it's an if. So this is an if nested inside of a while, like this. While end of file is equal to false. If pay type is equal to salary, then pay is equal to salary, else pay, you know. So here's the if nested in the while. Now this is missing something. It's missing something important. Your while loop should generally look like this. And if you've taken fundamentals of programming logic, you know this. You have an initialization step. And then you have your condition, your test. And then you have a body, whatever. And then you have an update. If you do not ever update it, then all other things being equal, it'll be an infinite loop. It'll keep repeating infinitely. Because if you know, something has to eventually change so that the condition is no longer true, or else it'll never leave. Even the body is not a necessary part of a loop, right? This would be a perfectly valid loop right there without the body. But those three things should be in every loop. Whether it's a for loop or a while loop or a do loop, you're going to wind up initializing something, and then you're going to keep running while that condition is true, but something had better eventually update it so that it's false. For example, int x is equal to 1, while x is less than or equal to 10,
x plus equals 1. If you left this out, it would run forever. X would always be less than 10. It would never stop. Now this doesn't have an interesting body. We should put some kind of print statement in there just so that we could see what's happening, right? And then we would see the numbers increasing, forever until they hit the limit of a signed loop, of a signed integer, and then went back around. That might be fun to watch, but you'd have to hit like 2 billion before, we could see that. Without this, it would run forever. So this is the initialize step. This is your test. And this is your update. Now, can you write loops without those three things? Yeah, you can. It could be that you're not going to initialize something. That sounds idiotic. What's this going to be based on? You could write a loop that looked like this. While true, x is equal to random number, whatever. And then if x is equal to whatever our random number is supposed to be, this isn't necessarily good valid code, break. Well, we still have a test, but the test is always true. So it looks like an infinite loop. But it's not an infinite loop because there's a way to get out of it. There's a break statement. Now, a break statement is an alternate way of how to get out of a loop. Now, if you're going to flowchart, then there's really no way to flowchart a break statement gracefully. What it looks like is, you'd have something that's essentially a go-to that goes to the end of the loop. And generally, we want to avoid go-tos, but breaks are so easy, so seductive, so powerful that we put up with them. So the idea behind this one is it would keep looping, it would keep calculating new random numbers, and then if our random number ever hit a special value, you hit a break. Why am I pointing that out? Because there's something known as a priming read. And a priming read is when you get a piece of data before you enter the loop, and then inside the loop, you ask again for that data. Oh, and by the way, I want to show y'all something. If this works. It does not. Okay. If you add the Sigwin binary directory into the Windows search path, then from the command prompt, you can call GCC and all the other parts. You don't have the bash scripting language, but you can still just pop open a command prompt and type GCC and run your stuff there. Well, we don't have that, so I'm going to run Sigwin. And I'm going to type in a while loop. The while loop is going to look something like this. What we're going to do is we're going to ask for a test score. And then we're going to do while test scores not equal to -1. Then we're going to add that to the total. But that's not good enough, right? Because that would just loop forever. We got to get a new piece of paper, a new test score. Ask for new test score. I'm going to change this to a little bit better. Input test score. I'm just going to call it test. Input score. Excuse me. I'm just going to call it score. While score is negative equal to all right. At input new score. Input score. This is what's known as a priming read. Why? Like priming a pump. Priming the engine with gasoline before you start it. It gets everything rolling. But then you have to repeat that code in here. That's duplicate code. It's code that appears in two places. I don't particularly like that. What I would rather do is something like this. Score is equal to 0 while score is not equal to -1. Then input the score. If the score is now equal to -1, then break. Or like this, if the score is greater than -1, then do our good stuff, total plus equals score. Like that. Now we have, I guess I switched between using braces and using ends statements. Let me make it look a little bit more like C. So you see what's going on here? The difference between the priming read and this version. This one does not require a priming read because we set the initial condition in such a way that it does go into the while loop. we get our data, and if the data is valid, we increment the score. This is implying that this program is going to say, please enter a score or -1 to quit. That's why I'm using a special value. That's called the century value. -1 is the century value. When they type in -1, it bails. The century value had better be something that's not valid data, but hopefully your teacher will never give you a -1 on an exam. So, that'll be good enough. That'll be our century. So before we input the score, we should print a message telling them what to type in, right? But this is just kind of pseudocode. I'm leaving some stuff out. Why not go ahead and do it? Output, enter score, or -1 to stop. And then I have to do the same thing here. This is getting you even more the idea that we have duplicate code right there and right there. Here we don't. Yeah, we're going to print out output, enter score, -1 to stop, but we only have that data entry code in one place. If I can write my code in that fashion, I will do so. That's one way I do it. The other way, I'm just going to copy this and paste this, is that instead of making sure it's valid data, if valid, then I change it so that if score is equal to -1, is it time to stop, then I break. And if I don't break, then I increase the total, like that. Two ways of doing that. What's the difference? Yeah, there's kind of conceptually a difference. You like having your if statement just change something and doing something if it's true, great. If you like having it break out, same exact logic conceptually. And so I guess I should lean towards doing it this way. And so as a matter of fact, that's what we are going to do when we write our little sample program today, at least one of them. I'm going to make a subdirectory, June 20, in my home directory, md June 20, or not, mkdir June 20. Yay. I'm going to type in pwd to see where I am. All right, sig drive C, users JG Thompson, launch textpad or notepad or something that you like. I'm going to go to my root directory, if I can find it. Why do I never remember where my root directory is? Okay, it's right there. I see it now. So I'm going to go into June 20. This is going to be a C file. The file that I'm going to create, I don't know, main. Or June 20 main. Main.c. Doesn't exist. Create the file. Alright, so now I have a file that I can go with. Except my font's too small for y'all to see. So never remember where to change the font size. Phooey. I don't know why every single time I get in here I have to do this. Colors and font. Okay, there we go. So I'm changing the size of TextPad. I went into preferences, documents, default, font. I can crank up my size. Alright, now we're good to go. It's still terribly tiny. What is the malfunction there? Configure, preferences. Okay, fine, for C files. There. Okay. # include standard.io.h. Just for fun, C type.h. int main. We're going to need a couple of variables. let's just represent a normal while loop first. So int x is equal to 0, const int limit, constant caps limit is equal to 10. We're going to count to 10. So while x is less than the limit, or I'm going to print out x. Printf, parentheses, quote, %d, \n, end quote, comma, x. And I'm just going to put x plus plus there. That's going to serve as my update. Normally I would do that. I'd put x plus plus on the line underneath it. But we're just going to play with putting the update right inside the print. Do I think that's the best idea in the world? Usually not. You'll see a lot of programmers do that. In fact, they'll put the XX right there inside the while. But okay. So I'm going to run out here and I'm going to make it. Well, I'm not going to make it. I don't have a Makefile. But I'm going to type gcc main.c -o main.exe. And you don't have to call it .exe, but if you're going to run these programs from the command prompt and not just from within Cygwin, alrighty, main.c, no such file. I didn't actually CD into June 20. I made June 20, but I did not CD into it. So CD June 20. Now I'm there. ls -a, and I should see my main.c, ls -l. Yeah. All right. And I don't know why I closed Cygwin. CD June 20. GCC main.c -o main.exe. And then /main.exe. All right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's about what we expected. If I wanted it to reach 10, I'd have to make that xn less than or equal. If I change this to -xx, what is it going to print?
Negative.
Yeah, it's not going to start at 0. So I'll do that. I'm sorry, I said -xx. Plus x. So it's not going to start printing off at 0. Why? Because it's going to increment it before it prints it out. So hit up arrow, compile it again, up arrow, run it again. So it printed 1 to 10. Maybe that's what I wanted. Most likely, usually, I would put this on its own line. There's no performance gains caused by putting it there. When it compiles it down to assembler code, it doesn't make it better assembler code just because it's on one line rather than two. However, we have seen, or we have said, that if you're going to put that statement on its own line, it saves a couple of cycles of computer time to put the ++x there early. And so this would behave back to the way we thought it would, counting 0 to 9, or if we put an equal there, 0 to 10, but we get our little performance gain there. All right, now we need to talk about prototypes. If you've used C++, or C#, you know what a prototype is. If you've used Java or Python, you probably don't. A prototype is a forward definition of a function. And the reason you have to use them is because C will only recognize a function if it's defined above the place where you're about to call it. Like, let's say I'm going to write some function that's going to print something. Void print x. And it takes x as an integer. And I'm going to move my printf statement in there. And then in here, I'm going to call print x, parentheses x plus plus, like that. That works. Well, I mean, yeah, I may have some syntax errors, but I compile it, I run it, it prints 0 to 10. Pretty much what I expected. I started at 0, it's running up to 10. All well and good. I was able to call this function. A function is a named block of code. Every function has three things. It's got a header, that's the function header. I think in C they sometimes call it a signature. Some textbooks do. It's got a more technical name than a function header. And then it's got a body, and it's got a return statement. Now C, along with a lot of other languages, if there's no return statement, because they're not required if you define your function as void, there's an implicit return. So there really is a return statement there. It's just it's implicit. Okay, so that's the header of the function. Function header. This is the body, whatever it was, and then this is the return. And all your functions will have those, even if the return is implicit. By the way, if you put a semicolon there, why is that an infinite loop? It's an infinite loop because there's no update step. There's also no body of it, right? We have our initialize, but we have our test, but there's no body and there's no update because it's essentially treating it like that. That's why putting a semicolon after a while is an incredibly bad idea, just like it is after an if statement. Alrighty, so if I took this code though and I moved it underneath my main, it's no longer going to work. If I try to build it, it says conflicting types for printx. Function header, note previous implicit declaration of printx was here. Alrighty. That's it. It's going to a lot of effort to tell us not the problem. For one thing, it's suggesting that we omitted printf. Well, that's awfully kind of it, to suggest that. The real problem is that it has not been defined yet. It has no definition for the printx. And since it has no definition, it doesn't know what the argument list is, it doesn't know what the parameters are, and it doesn't know its return type. And without those things, it can't compile it. It doesn't know that it was expecting an int, and it doesn't know whether or not it was returning anything. So you have to forward declare it. You have to come up here and declare your so-called prototype. Void print int. Your prototype is the function header, but just terminated by a semicolon. So functions have headers, bodies, and returns. So void, test, printf something. And then return out of it. That being the header, this being the body, however many statements it was, that being the return, whether it's implicit or not. And then a prototype is the function header with no body, ending in a semicolon. Used for forward declaring the function, so it can be called. So the compiler knows what it is. So if we go back here, we see that we declared it. Now notice I did not give it a variable name there. That's because all it really wants to know is what it accepts and what it returns. On the other hand, I find variable names to be useful information. So almost always, I'll go ahead and put the variable name here as well. Now I've made a serious error. When I try and compile it, it's still not going to work. Does anybody spot it?
Did you put printf?
Right, I didn't call it print X. So, print X, by the way, was a bad name because it looks so much like printf. But anyways, your function prototype has to, of course, be the same name as the function itself. Now, where you should stick your prototypes is in a header file so that they can be shared amongst multiple .c files. A very common programming paradigm is to put a whole bunch of helper and utility functions in one .c file, put your main code in another .c file, and define all the prototypes of those helper, those functions, in the header file. And that way, if you ever want to take those functions to a new place, you can do that. So we're going to do that. But I have to change the name of printf to something else. Or we need to write a more interesting function than that. Let's write a function called add, which takes two numbers and returns them. So int add, int x, int y. We can't do what we were doing previously where you do int x comma y. When you're creating a function header, you have to list each variable and its type separately. Okay, and so this is going to be int result is equal to x plus y. Printf, I am adding. And then return result. Now I'm going to go back up to my while loop and I'm going to call the add function. Just to prove that it works. So here, inside my while loop, I'm going to say int a is equal to add x comma x, and then instead of printing, I'm going to just delete that print x entirely. I'm going to call print x parentheses a. I want to see that number. But then I'm going to increment x. And I'm going to precede it for maximal speed. There we go. It's not going to compile because add has not been forward declared. Sure, I could just copy it and paste it above main. Yeah, you could, but you should define a prototype for it. So when you're done typing that, if you are typing, you don't ever have to type in the daily code. You can always just upload a note saying I attended and it was pretty awesome, wasn't it? Okay, so I'm going to take this and I'm going to forward declare it up here. Int add int x comma int y. And again, those variable names could be left out because all the compiler needs to know are the types. But like I said, variable names are useful information. Maybe not just x and y. But when you're writing functions, that do more important things, if you're calculating somebody's pay rate based on their, this, that, and the other, it's really nice to know. Okay, now it ought to compile, unless I have made a significant mistake.
Why did you use a void for now or not?
Very good question. What is the difference between a void and an int? A void means no return value. Notice this. Here I'm not returning anything. Here I am returning something. I could declare every function as an int and just return 0, right? That works just as well. But you'll see void. You'll see void used in C++, C#, Java, and all sorts of places. The difference is this is what's known as a fruitful function because it actually bears fruit. It returns something. And this is a void function because it doesn't return anything. Yeah, there's a return statement, but it's not returning a value like the add function is.
Well, I understand, for our main function, it's an int, but why is it not standard that it's just a void? I know it doesn't matter in C. I know it really doesn't matter what.
Well, Java doesn't have the ability to pass a value back to the command prompt because it's running inside the Java interpreter. But when you run a C program from the command prompt, you can check to see what its return value is. So this return out of the end of main, which I apparently left out, and the compiler didn't complain. If I had a return at the end of main, then the script that called it could check its return value and do something useful based on that. So that's a very common thing to do if you're chaining programs together with scripts. that make sense?
Mhm.
You're going to call your executable. You want to see, some useful bit of information. So that makes sense with the void. Enough to go on at least. Hope so. If you need to talk about it, well, again, we're skipping ahead because the book hasn't talked about defining functions, but we like skipping ahead.
My last part in print that I am adding statement.
Okay, I'm not sure mine does either because I never compiled it and tested it. Alrighty. Excuse me.
Did you
Alright, so mine is, so I'm going to come look.
call
In
above
here?
it? Yeah. See, like, you scroll.
That. Alright, I've restructured the code just an itty bit by moving the braces up onto the line above them, right? Just to save space on the screen. That's all I've done. So Deb, did you get it working?
Mm-hmm.
Alright, good deal. Okay. So let's move our print statement, our prototypes, into their own file, into a header file. I'm going to cut those guys, and then I'm going to do new file. I'm going to paste them, do save as. It's supposed to be a C file. I'm just going to call it funcs, F-U-N-C-S.h. F-U-C-N-S.h. Alrighty. Now have some prototypes. I guess I don't have to put that out there. I can put that there. And do you remember I had a constant of limit? I could stick my constant in here too, except I defined it as a const int. If I defined it with a # define, then I could stick it out here in prototypes. So I'm going to switch back to main.c, grab this constant int limit. I'm going to delete it entirely and move it to my header file. But I'm going to make it a # define. # define limit in all caps is 10.
Do preprocessors have to go before any statements? Or
No, you can
actually
mix
have-
preprocessor commands just as long as they're defined before you need to use them. Like that, yeah, like this. There wouldn't be anything wrong with me just going and doing, all right, I'm going to # define, my limit right there.
Okay.
That makes sense? Yeah. All right, now the code's not going to compile anymore because I've written the header file, but I don't include it. So I need to add # include funcs.h, but I better not put it in the angle braces unless I'm going to do a compiler switch to enable that. If you want to include files from the local directory, you need to use quotes rather than angle braces. Angle braces means it goes down the search path looking for them. Quotes means look in the current working directory, the same directory that the C file is in. Now if I save both of those files, funcs.h and main.c, it's possible it will compile now. But it's got a problem, which is, no, it's not got a problem yet. The problem arises when you have two .c files. And that's one of the places where we're going. We will get to a project where we cannot compile it as easily from the command prompt, and then we're going to make a Makefile in order to handle that. Did I close Sigwin again? Yeah, apparently. Alrighty. So GCC, and I better do a walkabout, make sure that everybody who's playing along. Okay, CD June 20, GCC main.c -o main.exe /main.exe or /. Okay, it ran. It compiled and ran. We successfully moved our files. Now something you will see a lot of people do is go into funcs and do this. # if def, or if, is it if in def? Excuse me. Yeah, okay, sorry. Didn't want to make a mistake. If in def underscore underscore funcs underscore underscore header underscore underscore, something like that, and then just copy that. Tab all this stuff, and then do #indif there. But also we need to define that variable itself. Like that. The reason you do that is sometimes you wind up in a circumstance where the same header file is being included by multiple other header files, and you could eventually wind up with something in that header file that cannot be included twice in the same .c file. It's got some global variable defined or some type def that's defined, something that if it appeared twice in a .c file, it would not compile. So what this is saying, and I don't have a good example cooked up yet, but we could cook one up. It wouldn't take us long to do it. But what this is saying is that the first time it is included from that same .c file, this is not defined. So it will do all this stuff. But if it's included a second time, then that won't be there. I'm going to see if I can cook up something. Don't necessarily make this change because I want you to see it failing. What if I declared a global variable here? X is a bad choice. G. It's really stupid to declare variables in a header file, but it works, right? Because all the preprocessor is bringing it in. So it's likely that if I save this and compile it, it should still work. All right, now what if I modify main.cpp, main.c to include that file twice? I think it's going to give me an error. Otherwise, this is a bad example of when to do it. Here we go. It is complaining. G was previously defined. Oh, and by the way, I want y'all at a certain point, and as soon as we start making Makefiles, to start using these arguments. Dash capital W, lowercase all. That enables all warnings, so you can see everything that's wrong with your code. Well, in this case, we had already told us what was wrong with the code. But warnings are useful as well as errors. Okay, so you see the problem is that my header file is defining something that cannot be defined more than once. But if I have this, if not defined funcs header, then do that stuff and define that funcs header, then even though it's included more than once in that C file, it's not going to fail. Now the question then is, well, why'd you include it more than once? Because you may have header files that include other header files. And that header file may include another header file. And when you bring in multiple header files, they could all be including that particular one. So I hope that makes sense. There's also a pragma, which does the same thing. That was introduced later. I have forgotten how to do it. Pragma, header, only once. Pragma once. Let's see if this works in C as well as in C++. I'm going to just do this. I'm going to comment that back out. You don't have to be making all these test changes that I'm making. I'm going to do #pragma once. Now can I still compile it? Or is that a C++ thing only? No, it actually works. Okay, so that's a shorter way of doing it. You'll see a lot of old code in that case that uses this kind of thing. And you'll see this is a replacement, a much cleaner replacement. Pragma once means only include this header file once, even if, you know, it should, by all rights, by the preprocessor, be included more than once. So I'm going to delete these lines, now make this change. That's a nice clean solution. I would recommend adding Pragma once to the top of your header files just as a matter of course. Okay, we're getting to the point where we're going to need a Makefile. But we need, pardon me?
Oh, sorry.
I do need to stop actually. I mean, do a walkabout. Yes, sir.
For my include, when I commented out the if-defs or if-indefs and have it included twice, it doesn't give me that.
Did you have a global variable defined in
Oh,
it?
no, I didn't.
Yeah, that's what I did to force it to fail,
Oh, okay.
is I added that line to it, which
Okay.
is stupid. I don't need that line, but I was trying to get it to break.
So it would only break if you put a global variable
Right.
in there.
Because
And
it's
you-
harmless to have these prototypes defined, and they macro definition happen more than once. But that was not harmless.
Oh.
So I'm going to delete that line, and then I'm going to pause the recording, make sure that we're all good together. Let's move these two functions into their own .c file. Oh, I no longer need to be including that file twice. I've proven that point. So grab print x and add, cut them. Or I guess we should create the new file before we cut them. I've done that. You cut something and then you do a whole bunch of stuff and you've lost them. But anyways, cut them, make a new file, paste, do a save as, and let's call them funcs.c. funcs.c. What's BOM mean? All right. And I need my header files again. # include standard io.h. I'm not using C types, but I sure do like having it around. C type.h. And by the way, I found a place where you can get a Boolean variable type. It's just an include header file. It's not strictly part of the standard yet. It'll be getting there, but it's an interim step. Anyways, let's save that.
If you include this C file like we're doing, does that mean our main C file, does it still need to include these as well, or can it use it from?
No, we're going to delete these out of our main C file. So I deleted them from main. Right now this is all my main has. And since you're doing Visual Studio, this is going to work all beautifully for you without having to write a make file.
Oh, I'm using VS Code, so.
Oh, okay,
So
okay,
I
okay.
make a file, yeah.
So I have two .c files. I've got a problem too, which is if I come over here and I try to make main.c, it gives me some grief. Undefined reference to add. Okay, undefined reference to print x. So what is this saying? It tried to link it. It tried to link it and it couldn't, because those things are defined in a separate .c file. You can compile without linking. gcc -c main.c compiles without linking.
But then it wouldn't run, right?
It's certainly not going to run. So now what we can do is gcc -o, or excuse me, main.c, and then give the other file name. I think this will work. funcs.c -o main.exe. But you can get the idea that if you have 20 files, that's going to get really annoying. So instead what we want to do is we want to make file. A makefile shouldn't have an extension. They don't stick extensions everywhere in Unix, unlike Windows. So what we got to do is we got to create a new file. File new. And then I'm just going to do a save as and try to get it to create something without any header at all. Make file, all lowercase. Now I'm going to go back to bash to cygwin and do ls to see. Nope, see what it did? It added the extension. So I'm going to close that file. I'm going to rename it. This is annoying. I should have just created a notepad from the very beginning. Even then you have that .txt you need to get rid of. Okay, so is it mv for move? Yeah. mv makefile.txt makefile. Or you know what? Just go and find the file and remove its extension. Right? You know, you can right click on it and do properties or whatever it's called. You can remove its extension that way. Anyway, no matter what you do, you got to get rid of the extension on the Makefile. You don't have to, because you can always specify which Makefile you need with the -f parameter. So if you had to, you could do make -f makefile.txt, but we don't want to do that. Okay, so now we're good to go. We have a Makefile. I'm going to try to open it. I'm going to go back over here, File Open, Makefile. It doesn't know what it is, so my text is teeny weeny.
Can I see you did? Oh.
I'm going to just open it in Notepad. File Open. Go to my root directory, wherever it is.
So like I made a Makefile. Do you know what extension Makefiles usually have? Are they just a file?
They should not have an extension at all.
Okay, so
technically
I already have the Makefile, then I don't have to make one if I have that there.
Right. Here's what I should have done, guys. This would have been a better idea. If I want to make a file, an empty file from the command prompt, I can do that. There's a touch command. If I do touch main.c, all it does is update the timestamp on it without doing anything. So if I do a directory of it, I will see that main.c has a new timestamp on it. But if you specify a file name that doesn't exist, I'm going to delete Makefile by doing rm Makefile. If you specify a name with touch that does not already exist, it creates that file. All right, so touch Makefile. Now if I do ls -la, I can see Makefile there. And then I can open it. I'm going to do a walkabout, make sure everybody's got that dang file open.
Is that like an unintended side effect of that command, or is it just how that works?
Is it intended that way? I don't know. But it's used all the time.
I'm sure they just left it like that. Yeah,
It seems like a hack, doesn't it?
cool.
But
It seems good. It's one of those unintended bugs that works in language and But you stop. I'm sure you did that. Let's look it up.
you know what I just need to do, and I'm ashamed that I hadn't think of it before now, is drag my home directory over into the favorites so I can get to it really quickly.
All the rock.
Okay, so anyways, now I have my Makefile with no extension ready to go. The way you execute make is just you type make from the command prompt. Now there's no targets, nothing to create. I have a PowerPoint over make. If you want to go and look in the PowerPoint directory, you'll see it. Everybody got a Makefile open who wants to have one.
Okay. So I'm gonna just go through what I did first. Okay. So clear. It removed it, the
Okay.
file, and then if I just
Touch.
touch, sorry. And then it creates that.
Right.
And it's already a Makefile.
Right,
Okay.
right.
So that's what it's.
Or at least it's a file with no extension that we can start adding some text into.
Right, and then, so in our main, you're saying that I can get rid of these includes?
I wouldn't.
Oh, I thought, well, because when I asked you if we had these includes here, does that mean those are also included in? If,
We could
say-
move those,
say-
yeah, if you have a bunch of includes, you can move them to the header file, but I wouldn't. I would just leave them there, so maybe I misanswered your question.
Oh, okay, I was asking if you have another C file and you having these included, are they, and you include the C file in your main, will those?
Okay, you never want to include a .c file from
Okay.
another one.
Okay.
Got your Makefile ready to cook?
But it's not.
You're ready to go, though. We haven't typed anything into it, but we will.
Okay.
Okay. Good, go on the back. Back here. Okay. So Makefiles can get really nasty and complex looking.
That's good.
They start off easy and then they get worse and then worse and worse. So we're going to look at the easy one first. So open up C PowerPoint 7 Makefiles. All right, here's the simplest one. What you do is you define your target. In this case, it's going to be main.exe, and you list all the source files of it, and then you have a GCC command that will make it. So let's see if we can get that cooking. I'm going to go to my makefile, hello.exe, and it's no, it's not called that. Main.exe, colon, and what files comprise it? Main.c, funcs.c, and funcs.h. If any one of those files change, we want it to recompile. If it needs to recompile that, we're going to execute GCC. GCC minus wall main.c, funcs.c, and then create our output file, -o, main.exe. Then I'm going to just kind of tuck this away and minimize it and try to run make from. Can I clear the screen? CLS, clear? Yeah, clears the screen.
So is Makefiles like old scripts? Is that
Yeah, it is effectively a scripting language with its own macros, which we'll see soon. Macro substitution.
Mine says command not found.
All right, guys. Once you get make installed, if you didn't have it installed, and for those watching at home, what we had to do is we had to rerun the Cygwin installer, find the make utility, and tell it to install it. I should take a screenshot of that. Okay, so anyways, here's our simplest make file. If I type make, it runs. Now, it doesn't need anything anymore, right? It's already been made, so it's going to say make is up to date. Now I'm going to touch one of those files, touch funcs.h, and then I'm going to make it again, and it makes it. So anytime you make an update and save it, make will go ahead and compile it.
Mine says no rule to make target.
That's fine. Go to your make file and add this stuff and save it.
I did.
How's it go back here?
Whoa, Wi-Fi.
I can't hear it.
No,
So it's killing me. Oh, man. I literally just copied like one of my files and put in another one, so it's probably like freaking out because I didn't do that.
Yeah, we have multiple mains. You have to.
Oh, I mean,
Yeah,
I
you see what it's
just
doing
one
is it's
main.
compiling them all.
Yeah.
Rename one of the mains to something else, and it would conceivably
I don't know.
compile it.
Like what? Just like, can I just
Main
delete it?
2 or.
Let's try.
Multiple definitions.
Hey, we got rid of one line, so it's good.
Wait, so it's the same exact code?
Yeah, I just copied and
Oh,
pasted.
that's all it
Yeah,
was.
so somewhere we have add declared twice. Where's your today's code? Is this today's code?
Yeah.
So we have add defined down here.
Oh, so I can't just.
So if it's in funcs.h as well, remove it. Remove it from main and just leave it in funcs.h or no, funcs.c.
One less.
All right,
Yeah,
just get rid of that
yeah,
G
yeah,
thing. Get rid of that G thing. Actually, I'm disappointed it's doing that, but come over here and delete.
Yeah, another line. Hold on.
And what do I mean by that? That pound sign if and, oh yeah, it's when it's linking into the CMS. It's really a bad idea to declare a global variable in a header file. We're seeing massive problems over here by that.
Okay, cool.
All right, guys, so we're going to look at the more complicated version of Makefiles. Here's a slightly better one. This one has a few options. We've been using -wall already, so I don't need to talk about that one. But then there's also -i dot, which includes the current directory in the C processor. What does that mean? That means, did I close TextPad? That means if I wanted to, if I had that in there, I could include funcs.h like that. That means that later on, if you move funcs.h to your primary source repository, it'll work great without you having to go in and remodify your code. You don't have to do that though. I'm going to leave that alone. I just wanted you to see that. That -i, the thing that follows the I is the path, the search path that you wanted to include. So if we were going to make a subdirectory that we needed to add into the search path, we would put that subdirectory there. Alrighty. Now it's getting a little bit more fun. We're going to add a command here called clean. So we're going to add a few things here. Actually, we're just going to add one. And then we'll come and add the other one, I guess. Come up here and do clean. Go back to your Makefile. Add a new target on its own line. Clean, colon, hit enter on the next line. I don't even think it has to be tabbed over, but it makes things clear. RM for like remove, and then delete main.exe. Now the reason we've done that is so if we want to start rebuilding things, let me clear the screen again, I can type make clean. And you see what it did? It removed that file. I could run as many different commands as I wanted to. You see that main.o file? That was left over when I told it to compile but not link. Maybe I want to remove all the O files from my directory. So rem star.o. Make clean. Well, what do you know? Alrighty.
Star.o, so that removes all, what's that?
The WAV, yeah. It's the joke. He made like a O file earlier, but he doesn't want to. Reformat C. Let's make a macro for that.
Well, since when did rm start requiring that file to exist or it generates an error? But anyways, okay. So we should be good to go. If I do make main.exe, it should still make the other one, right? So I was able to specify the target. You could list as many targets in here as you want, and then when you issue main, it'll make that one.
So if you don't, so if you just put make again, it's going to run everything inside of it?
That should not be true.
Okay.
Main. What it does is the first one listed is the default.
Okay.
So this is the default, but if you specify clean, it's good to go.
So what is it removing?
I just removed the .exe file, and that .o file was made when I compiled, but I didn't link. What I did is gcc -c, which tells it not to link, just to compile, and then I did main.c. It made an O file,
Okay.
If you
called an object file.
If you wanted to store the executable in like a different directory, could you point to where it's located?
You could in your gcc command. When you do that -o, you could specify a subdirectory like that.
Okay.
That would make it. Yeah, the question was, what if you want to put main.exe in a different directory? You could specify that directory after you do the -o, which means the output file.
Because you know how like Visual Studios has like a debug and
Right.
release.
Just like Visual Studio puts a debug in a release directory.
Yeah, so like whatever old version it was, it's not executed, so you don't do it the new version. That's why you
So coming up soon, macros inside of header files, because we love macros. All right, so here's this example. Maybe we won't type this one because I think I have a better one coming up. But project equals hello. This is my macro. If I want to expand it, I expand it like that. $ project. So this makes a new macro, and after this has been expanded, it'll be hello.exe. Maybe we ought to do this. And then I have one called src, and I list all the header files. Yeah, why don't we do this? Why don't we do this? Come up here, and let's add some macros. At least this one. Source is equal to main.c funcs.c funcs.h. And then here, put $ parentheses src in parentheses. And in our list of files to compile, do $source. And let's test that before we go any further, before we keep hacking our file and making it larger and larger.
we're just making this file bigger.
So make, well, great. Make clean, make unexpected token near parentheses.
So you have an at instead of a.
Yeah, I have an @ sign. You're right. Thank you. I needed a $sign there.
Oh, I see what I missed.
All right. It did not. It gave me a warning about that pragma. Didn't like it. So apparently I should remove that pragma.
So wait, I got a question.
Sure.
We did the GCC before. We didn't put the H file in there, didn't we?
You're right. And that's what's happening now. Exactly. Is it's trying to compile funcs.h. So tell you what. Take funcs.h out of the source and put another macro called headers or something like that. Funcs.h. And then here in your list of files, do $ headers, but don't put it in your list of files to compile. Excellent point. And I was puzzling over why we got an error there. And that explains why. So you see what I've done? We have our list of source files here. And that's all that we want to compile, but we want to trigger a compilation if the header file changes too. So make clean, and then make, and it worked. So what about this one? Pardon me.
Multiple definition.
We're all here, but okay. So what I've done at this point is, and I stopped the recording, so I'm reiterating, is we defined our macro exe, and then so as our target we put $exe, and as our output file we put $exe. And then on the last pages of our PowerPoint we see a really lengthy version of it.
When we turn this in, do you just want us to zip the whole folder and give it to you? Or do you just...
That's true. When you upload this, it's not going to let you upload the Makefile because it won't accept files without extensions. Thank you, D2L. So you're going to have to zip it. Okay, so let's go ahead and make a Dropbox for it. And please give me those files. Oh, there was an assignment coming up involving loops. We didn't get far enough in loops to actually assign the assignment. Good thing y'all know how to read. So let's go and look at... Dude, we're only like on page 2 of the PowerPoints and the homework. All right. I am going to create the homework, but I'm not going to make it. It'll be due next Wednesday, right? But, oh gosh, how am I going to handle this? We're not going to have another lecture before that. I'm going to have to make it due a week from Monday, to be fair. But if you know already how to do this stuff, which you probably do if you've taken another language, go ahead and knock this homework assignment out. Create a counting program that counts from 1 to 100 in increments of 5. You could do that with a while loop. You don't have to use a for loop. Create a counting program that counts backwards from 100 to 10 in increments of 10. Create a counting program that prompts a user for 3 inputs. I don't know why shown next is there. That determine how and what to count. Store the user's answers and variables and use that data to build your counting program with a for loop. So if you want to count from 1 to 100, make it do that. Now making it optional so that it'll allow you to count up or down is quite a little trick. So you don't have to handle that if you don't want to. And then beginning the number to start from, the ending number to stop counting at, and the increment number. That's how we want that to work. And so like I said, if you can get this done because you know how to read and stuff like that, great. If you want to wait until Monday to start working on it, one more lecture, that's also great. I really wanted us to cover Makefiles today. To me, you already know loops and stuff like that from other programming languages, but you probably didn't know Makefiles.
We did not know it though.
All right, let's make a Dropbox. So how do you zip this stuff up together? You go and you find the files that you want to compress. You don't have to give me the executable. You might delete the executable. You don't have to give me the .o file if there's one in there. But otherwise, highlight all the files you want, and you probably already know this, and do send to compressed folder. And that's what I want. You feel like giving it a better name, like june20.zip, that's totally cool. The reason you have to zip it is that D2L will not accept a file without an extension. Alrighty then. So A, B, Z, D, E, F, G.
Do you have to name your Makefiles Makefile? Or do you name them something different?
If you can, yeah. Do you have to name your Makefiles Makefile? No. If we renamed, or let's at least copy it. Copy Makefile into m2.txt, you know, txt. Then when you ran make, you could do -f m2.txt, and it'll run it. So the -f parameter lets you specify a file name.
So it just defaults to Makefile.
Right, but it defaults to Makefile. That's correct.
So, like for a Makefile, it's like it's in own language, like.
Yeah.
That's cool.
Yeah. All right, there's a Dropbox G, and I'll create the homework folder. It will not have the homework assignment in it right now. You could grab it from the PowerPoint. So HW4.
Oh, when I did that homework, when I was doing the random numbers or whatever,
Yeah.
like they weren't very random, so I had to do like something extra to make it random.
Very, very, very true. The random number generator is stinky because it's going to generate the same series of numbers every time. That's what you were seeing, right?
Yeah.
Yeah, and the reason why is that a random number generator has to be seeded with a value. And based on its seed, that's just a starting point. If you give it a different seed, it's going to generate a different series. But if you keep giving it the same seed, it'll generate the same different series every time. So what people do is they seed the random number generator with the current time in seconds, so that way it'll always generate a different sequence each time. Very, very good point. Let me save that file where we were.
I just put ×0 on mine. Is that the current one?
Exactly, right. So yeah, if you already found out how to do it, that is totally cool. If you don't do it at all, that's also okay. But rand seed C programming.
Is there a difference between ×0 and time null?
No,
Okay.
no. SRAND lets you seed it. So all you have to do is what you see here. Here they pass in a variable to get the time. Yeah, right. Okay, I lied about seeding with time 0. Is the time value, did it return something to you? Is that how you did it? Something like t is equal to time?
Scroll down some more. Scroll up. It was like, I looked at like one of the similar pages. Go back to your search results.
Yeah.
And then do. What did I do? I think I typed in just rand and C.
Okay.
Or try that first one.
Whoops.
Yeah, that one.
Geeks for geeks.
That's right. Keep scrolling. Keep going. C times 0.
Yeah, see, they were showing passing a value in with a pointer into the time function. I would just do it like that. In order to get this to work, you're going to have to include time.h in standard lib. So let's just, I'm going to copy all that and paste it into our news just so that it's easy to find.
You know, I don't even think I included time.h.
And it still worked? That's cool.
Yeah, it just gave me like a implicit defined.
Yeah.
So if you don't